Hello and welcome to another episode of Hedgehog Makes. My name is Austin, aka Zombie Hedgehog, and today we have the Tapchanger, Stealthchanger, the Voron Toolchanger Part 4, where we now have two tools. I can't believe I got this set up correctly, but we're here. It was actually pretty easy. So in today's episode, we'll be talking about the progress I've made since last episode, which I'll have to remember. And then just, show off the Toolchanger, just do a brief explanation of what the project is again, and kind of how I got it working. There we go. So, that being said, I'm streaming this live on Twitch. If you're watching on YouTube, make sure to hit that like button and subscribe if you're not already. Leave a comment down below once you're done with the video and let me know what you think. Are you going to build one of these? Do you know someone who's going to build one of them? Be very excited to hear your feedback on it. So, who do we have in the house today? We have KB3D Chris, Hellspark, Silent Assassin, Cybernet, Hybrid Robotics, Incendium, Mark H, Pez Liz, Firefly, and of course anyone else who might have just popped in. So yeah, we have a Toolchanger. We have a Toolchanger. It can change tools. Now, a couple of asterisks here. The wiring is not finalized. I don't have proper cable management, so if there's any failures today, it might be just tangling of cables. So I'll be addressing that in what the fix is. But if you are new to the channel, welcome on in. This is a Voron 2.4 350 kit. This is actually an LDO kit. Thank you to LDO for helping get this kit for building and modding. I wouldn't even call it building, it's just like modding. So we built it mostly stock and had some amazing results. I got some of the best prints I've ever done have been on this printer, which is very surprising because it's a 350. You wouldn't think that a 350 would work this well, but it does. So thanks to LDO kit, I'm able to get extremely high quality out of this printer. And then we added tools. So where did I leave off last time? I think I just had, was I even printing with it? Wow, it's been a few days. So if you missed what happened between the last episode and now, I do stream these live on Twitch. So make sure you're watching. And I'm thinking about uploading some VODs in the future if you aren't able to attend. I'll just upload the whole entire VOD, probably to a second channel, but this is a specific channel for this Toolchanger project. So I don't have this thing printing yet with two colors. So let me just do a brief demo to kind of catch your attention. Let's do a home all first. So we are going to home the printer. We are going to level my camera a little bit. But nothing's ever level, right? All right. And then, moment of truth. So it's worked a couple times. I haven't fully tested it. I am just worried about the cables, but hey, YOLO. Let's just do a standard docking procedure. So we're going to dock and undock this one red tool. All right, it's docked and it is undocked. Yay! We did it. So that's the easy one. Now, let's change tools. So let's change from tool 1 to tool 0. All right, it's docking the tool 1 and then picking up tool 0. There we go. We've changed tools. It is a thing. Tool changing is a thing. So there we go. We just got this working a little bit before stream. I wanted to make sure that we were set up for tool changing beforehand. So there's a couple things I have to change. You rather call me tool 1 and cool? Nope. That is Tool 0 and Tool 1. I hate it, but it's not. So yeah, Tool 1 is not what you think it is. Get a print started. We can issue a serial. Well, let's see about that. Number 1, we don't have the slicer set up yet for it. Number 2, we don't have it calibrated. So I do have an Ember Prototypes CXC coming in, I think tomorrow. So I'll be able to do an accurate calibration of the tools, but for now we'll have to just YOLO. All right, so I'm gonna go and a couple things I have to edit. I'll just go over my config real quick with you. So we're inside of the Klipper config right now. And if you're interested in running this Tapchanger, doing anything with this project, you will have to run Klipper currently. I believe someone is working on a RepRap firmware version, but it is going to be infinitely easier to run Klipper, and it's honestly not too difficult. So probably after I get everything completed, I'll go back and clean up all this config and then post it, and maybe do a video on it. No promises. If you have any questions about the config, make sure to join the Discord. Not my Discord, you can join it, but join the Voron Toolchanger Discord. Well, they'll be able to help you with all your issues, solve everything, and work miracles. It is very exciting. It is. All right, so right here I have Tool 0. This will eventually be in its own config section, but for now, for ease of use, I just have it in here. So Tool 0. This is the settings. So we have I have the resonance tester set up for that tool, just so we can run some, experiments with the ADXL. I'll be using a different ADXL for the final measurements, but it's a good start. The extruder, this is running CAN bus, so I've actually named this MCU ET0. So that is what I named this first EBB36 board, ET0. So all of these ET0, this is my pin that's on this board. So that's just that's how it works. That's how it's laid out. So we have our extruder. So this is pretty standard right here. So we have an extruder. We have an extruder here. Right here, we have a multi-fan. So I don't know specifically why this exists, but this will allow us to have all of our fans controlled, because Klipper supports, by default, 1 fan, but we have 6 fans. This is for the part cooling, right? So we don't want to activate all our part cooling fans at once. We want to activate it for a specific tool. So I think that's why we have that. And same thing for the tool head fan. We have a specific little macro set up for that, which is a very simple one. Just either it's on, the hot end fan is on when the extruder's on. Simple. And then we have some things. So I think this right here should be T equals 0 for our macro. I think we'll have to edit this, but this is just a macro that puts a T0 in where the extruder is, and allows us to switch our tools manually. We have our tool T0, which this tells where the actual dock is located. It tells how to dock it. If there's a XYZ offset, which we'll have to investigate once we get both tools working, and then how fast we're docking. I like the path speed. Right now it's at 1500. That's pretty fast. You can lower it, increase it, etc. But that's just how fast the whole docking mechanism works. The slower it is, the generally more reliable it's going to be. But we're going to try to push this printer to see how fast we can change tools. And then this is very important. Tool underscore probe T0. This is our probe. This is our tap. So this is the same exact probe settings, but just here, because every single tool is a probe. So depending on what tool is located, it'll act as a probe. So I'm gonna have to, again, dive deep into, whether or not probes are, or not probes, but we're gonna have to figure out how everything's calibrated. Personally, I haven't done a lot of research on it, so we're gonna learn together. And then right here, this is the standard G code for running a tap. It would essentially just heat up the hot end to 150C, and that makes sure that if there's any filament on the edge, it gets smushed. But I've commented it out and just replaced it with tap probe activate heater equals extruder, and I'm just gonna delete this because it is no longer needed. When I was running it as a single tool, that's what I used. So that's that. And then we have tool 1, which is our second tool. Same exact thing, we've defined our CAN bus, and now instead of extruder 0, it's extruder 1, because we start counting at 0. 0, 1, 2, 3, 4, 5 for 6 tools. So extruder 1, and that's very important. Every time we're referencing an extruder for tool 1, it's extruder 1. If we're talking about tool 0, it's just extruder. There's an invisible 0 there. So extruder 1, same exact config, identical config because these are identical hot ends. Extruder 1 here. I've also named the EBB 36 ET1, so I'll keep that naming convention going forward. And then I think this is a macro that was causing me some issues, so I'm gonna... Oh yeah, I think I know what the issue is. I'm gonna do T equals 0. Should it be select tool T equals 0? What was it? T1. So should it be select tool? I think it's select tool. That would make sense. Because it did work to switch to 0. So let's select tool T equals 0. I think that is the appropriate command. We'll test it out. And then T equals 1. So those weren't the same. All right, cool. No equals. Well, that's what wasn't working last time. Or was it? Hold on, what was working? Let me go back. What was working is T equals 0. Or just T0. I mean, doesn't that call the same thing, the same macro? I don't know, it's weird. We could try it. Select tool. Okay, let's see. So it should be select tool. Ooh, jeez. Tool equals tool T1. Oh, jeez. Is that actually how it works? So you're saying to do that? That's what you've got? So, like that? Stop tooling around. Yeah. Let's see. So, I'll comment this out, and let's try it. Why not? Tool T1, save config. So everything is all the same. We're going to delete this right here, and that is the config. And yes, we're going to have each tool in its own file, but for simplicity, I just put it in the printer.config. Same thing with the macros. So let me go back and we'll do a home. The homing sequence is what, I don't know where it's located, but this is the kind of optimized sequence. So it starts by homing the y-axis, and then it reduces the current for the X, and then homes with sensorless homing. So that allows it to be extremely repeatable, because sensorless homing is not the most accurate thing ever. So we're trying to make it as accurate as possible. So we're on tool 1. Tool 0, let's change to tool 1. Okay, that does work. Just watching the wires there. It's wild. I think I have a little bit of alignment, misalignment on tool 1. I actually picked a value and it just works, so I'm pretty happy with that. So let's switch back to tool 0. I also have it switched a couple times. Make sure that it works. If you're going to be building this printer, I strongly recommend just spamming, tool change or, loading or whatever. Just change the tools around. Yeah, I can see it's kind of slightly off on the X probably. But it's a super smooth docking motion. And these are just the beta docks, I'll call them. These ones use screws in order to hold them in. But there's going to be some additional docks coming, so the whole entire docking layout might change. But that's what it is for now. There is a tool change demo. I don't know what that does, so let's see. We got a YouTube sub, thank you very much. Okay, so this goes up and down. Yeah, that black wire at the top is not ideal. I guess it still kind of works. It gets out of the way enough. Yeah, very cool. I kind of want to fix that the X and see what's off about it. Is this going to run infinitely? What's the Z speed? So right now it's at 150 millimeters a second. That's a really good balance between speed of tool change and noise, and I guess not necessarily accuracy, because you'll never lose steps if it's working normally. But I don't want to move too fast and cause it to lose steps. See from the other side. I don't have an easy way to get the camera that high right now, but maybe I can turn around and show you. At least like seeing what you're seeing like this. The cable's not too long. I'll try. I took a video on... Actually, I'll just post a video when I'm done with this so you can see it. Looks like it's working out. I'm also noting that these are not the correct pins. So the way that this docks is there's a pin that goes into a... what are we calling these things? Sleeve? Bushing. There you go, bushing. So it's a pin that goes inside of a bushing. And my pins have a flat edge where they should be rounded. So in this situation, it has to be perfectly aligned, or else it'll just hit the edge and then knock the tool off. But with the curved pin at the bottom, that should allow for some slight misalignment or some slight tilting. So yeah, wow, that's it. That's it. So before we do any type of calibration, before we try to test anything out, number one, if you have any questions, now's a great time. But two, we are going to just check the alignment of the red tool. Eventually, it's going to be in the order of, proper order of the rainbow. So Roy G. Biv. That's why I printed off the red one, because I just had green loaded when I was prototyping, and you know what happens if the filament's loaded, it gets printed. All right, so we're gonna do a tool align test. Tool align start, and that will put it far away. And then we can go to the printer itself, and I'll zoom right in on this best I can. Go. So I am going to just go on my screen and jog the y-axis forward. So 5 millimeters at a time. So this is how you align the tool, essentially. So you want to move it forward until that's too much. Shoot, we lost steps. Okay. When you get to the edge, you want to just go very slow. But now we've lost steps, so we have to rehome it. That's also very important. If you do experience a crash, whoops, just back it back out and then rehome it. Let's home the XY. I don't think we need to home the full Z. And then we'll resume the... I'll just rerun that macro. I'm not used to switching macros on the screen, so I'll be using my computer for this. Tool align start. Move out of range. Move out of range. Tool align start. Interesting. Where's it trying to go? 400? Oh, it's trying to go up? Wow. Interesting. Well, I guess we'll home all. More tools means more filament loaded to select from. That's true. That's one of the great things I love about the bamboo, is that I have 12 colors on tap. Not necessarily that I want to print in 12 colors, but just having random colors available. How close to max Z is that? So the maximum Z is, in my case, I think until I run out of rail. So we're pretty close up to 350 for the max Z. And I'm docking at 347. So it's right at the top. Now there's going to be all kinds of mods. There's going to be different styles of docks that will actually lower it. Someone's working on a mod that will move the dock, the whole entire dock up and down. So we'll see how that works out. But there's going to be a lot of options. Remember, this is a very, I'm not going to call it simple, but this is a reasonably simple design. That's why I love it so much. And that's why I feel like a lot of people are going to want to build it. Because you can just add it to your printer. Once the team who's developing this gets everything, all the bugs, all the kinks worked out, all the bugs tuned, and all the testers tested it. I'm a tester, by the way. This is considered beta. But it works well. It actually seems to work well, and I can see the mechanism working very well for a long time. Not only that, but this is just all printed parts. Eventually, this could be all CNC'd. You know, that's not impossible. And I don't have a specific answer on why you might want to go with this over a Trident style. There's actually advantages of having a servo-actuated tool change, mostly speed. But I think this is a pretty good option for a lot of people, especially people who like already printing on a 2.4. This is the most popular Voron printer by a long shot. This one right here, the 300 2.4. This is the most popular Voron, as far as I'm aware. So why wouldn't you want to take the most popular Voron and turn it into a tool changer? One builds a Voron 2.4 and later wants a tool changer would be difficult to convert. Not difficult, but all you have to do is remove the drag chain if you're running a stock drag chain, convert to umbilical, and then add some tools. Probably the hardest thing is just CAN bus and getting that working, and additional wiring, and spool management. It's really not the worst thing in the world to convert. That's why I like it. It's not like a complete overhaul. You have to rebuild the frame. You take an existing 2.4 or maybe even pre-built 2.4 style printer and then just put some docks on it, build out these little tools, call it a day. So let's try this again. We're going to do a tool align start. And then make sure this is properly aligned. Yeah, it's an upgrade path for sure. Now, I'm hoping, my goal at the end of this is that we can work with a manufacturer to get a, let's just say, kit that has like a reduced BOM, if that makes sense. So, you know, typically you would buy a 2.4 and you'd build it, and then you'd have all these extra parts. But that's not ideal. It really isn't. Sure, you can use some other printers, but you might not. You might not want to, you might not even have a printer that could use them. So I'd like to see a reduced BOM parts kit for this printer that comes with pretty much everything. So either just a base 2.4 that you can add whatever tools you want, or even like a tool kit. I might be working with a couple vendors, manufacturers, and getting that rolling, but we'll see how this works first. All right, so we are at y equals 6. That's about how far I need to be away from the front. And then my Z is at 347. So I'm going to move my Z down 1 millimeter at a time. It should be locked. Yeah, it's locked in the tool, and I'm moving it down. And I'm just observing it. All right, so it kind of tilts a little bit forward. Let me give you a better view of this. I should be able to just tilt it sideways. And then get as close zoomed in as I can. Make sure you have handles on this printer. It does get very beefy very quick. So that is, oh wow, I can't access it anymore. Well, you get what you get. All right, so Z down. So we're just gonna, kind of just go up and see what happens. It should be a very, very smooth transition. So what I can see is the tool kind of sits back. In fact, it wasn't actually docked. That's actually very important. In this case, it was tilted back and it wasn't on the front peg. So I think I might need to move it forward a bit when I go to dock it. Let's move this back up. Where we're at, Z equals 347. And then we're going to move in steps of 0.1. So we move the Y approximately 0.5. Yeah, we'll call it 0.5. And then we'll try that same move again. So it's moving the Z down 1 millimeter at a time. We're going to see if it docks in place. This time it did. This time it doesn't fall backward, which is good because we don't want it falling out. And we're able to move our Z up and down. Now, as it reapproaches the pins, I'm going to watch to see if there's any... I should be able to look at it and see if it's above there. And I think I might need to move it over ever so slightly. So let me just move it up right next to it, and then give it a visual inspection. Chuck Guy, thank you for the follow. So yeah, okay, I definitely need to move my x-axis this way. So it needs to go ever so slightly in that direction. And I can see that on both sides. So I'm going to move my x-axis ever so slightly over, and then see if that looks like it aligns better. And it looks like it might, so we'll try that. Can you build a stock Voron 2.4 and go with a Dragon Burner? Does it make the conversion easier? Not necessarily, because you'll still have to rebuild the entire, you'll take apart the tool head. But if you go with the Dragon Burner now, that does give you the fans right away. If you can and want to, just go with the Stealth Burner. Stealth Burner is the most supported tool head in terms of like the most people have it. So it'd be a good idea to start with that. But I'm a huge fan of the Dragon Burner docks, or not the docks, but the these things. The Dragon Burner mounts for different printers. So this is a Dragon Burner mount. Hello. Hello? Do we have autofocus? Nope, there we go. So this is a Dragon Burner dock for a 2.4 Trident, etc. So that's what it looks like. So this mounts against the gantry on a standard MGN. Ah, it's dark over here. So that's what you can use to install it. But if you go with Dragon Burner, currently, I don't think drag chains are supported. So if you're gonna go with pure stock, I think that you should just go with a stealth burner to start. If you're an advanced modder and want to go straight into umbilical, then go for it, okay? But your mileage may vary. All right, we're at 63.1. That's good to know. So let me try to undock the tool, or move it. So X, not X, Y, Z. Let's go Z up. That, and then we should be able to go back. There we go. And then I am going to, I need a macro that just puts the nozzle in the center of the bed. Because if I just hit, you know, go to Z, it's gonna take 10 years. So I usually just do a QGL, which says, see you later. So I gotta edit that. So what was that value? I think we had 3 clicks over. So let me go into my printer.config and then edit that tool. So that's tool 2. So you go wherever your tool 2 is, or T1. And then right here. So these are the parking parameters. This is where your dock is. Let me zoom right in. So my X was at 63.4. I'm going to change it to 63.1. And you're going to go as fine as possible to get that exact position correct. And they also had to move this one up a bit. So this was at 5.5. So we'll see if that works out. All right. Far too much. Too much zoom. Too much zoom. Ah! There we go. I like it at 125%. Let's go back to here and then do another home all, QGL. I've just been doing QGL. It is not necessary to quad gantry level every single time you home. But when we're testing this type of thing where we're changing tools, I think it's worth doing a QGL just in case. It takes, you know, a minute, etc. Let's go here. So let me set this back up and we'll just do that same exact macro where we change tools a bunch of times, the demo, and then we'll see if that gives us repeatable results. I love the Dragon Burners on the 350 because it looks so small. It makes the printer look huge. Center macro. All right, cool. It's very useful. Is it centered right above the bed, though? Where is the variance on Z between tools? What is the variance on Z? What do you mean by that? All right. All right, let me do one more tool change demo. And then we're gonna start trying out some calibrations. How much different there is in height? Height where? Like from tool to tool? The actual nozzle height? Yeah, okay. Yes, that will have to be calibrated. So there is a kind of a cool little calibration gizmo that you can print. It'll automatically calibrate all the tools for you. But I have opted to not use that. I probably should. But for now, we're going to do it manually. And then I'll use the CXC for at least XY calibration and try that out. But yeah, what would be the best way of finding the correct Z offset? We'll see. There's a lot of config with this, and I'm doing this for the first time. So once I'm done with this, I'll be able to share with you my config, and it'll make it easier for you. And then, of course, I should probably do a video on like how to calibrate your tool head, as well as the original designer. I think they have a video too. Yeah, it's an XYZ offset that you set per tool. So we'll be able to modify that. You got one that's a micro switch and a ball bearing for simplicity. Yeah, that seems pretty useful. I'm considering setting up like a sex bolt in the back there for just nozzle probing. I think that would be good enough for the Z offset, assuming that the nozzle's clean, etc. Because we're getting them tool to tool, we're not looking at the first layer offset. We're just trying to get repeatable tool offsets. XY is harder, so nozzle offset tool helps. Yeah, XY is very difficult to get precise. That's why I'm excited to try out the camera. So tap is interesting because tap has its own offset, and it's not tool to bed, it's the sensor, right? It has no idea, the sensor has no idea where it is. So you have to calibrate that offset. But once you get it calibrated, it'll always remain the same. Oh, I'm trying to figure out what to do from here. Well, let's do this. Tool change demo and see if it actually docks with these new settings. Okay, it looks like it does. So we should be looking for a super smooth dock. Really smooth. We don't want any play, any fuss. That looks pretty good. So as good as we're gonna get. Yeah, load cell will be great. There's a lot of really awesome things that I'd love to have for this printer. Oh dear, how long has that been on focus for? Is it focusing? A little better. There we go. Like, I could just watch this for hours. It's so cool. And this is just 2 tools. We're gonna have 6 total tools on here. 6. That's crazy to me. 6 tools. 6 possibilities for 6 different types of filament. My mind is just racing, you know, trying to see what I'm gonna print. Am I gonna do a really cool TPU and PLA print? Maybe dissimilar materials that, are print in place? Crazy. I don't know. I'm most excited to just test things out. Just like random materials, things that no one else has really been able to test because not many people have a Toolchanger. Even with the Prusa XL, I don't think there's many people with the Toolchanger. How does it handle oozing? That's a great question. So, not installed, but I can show you. On the actual dock, so here's the dock if you're wondering. On the dock, there it will be 2 screws right here, and there's a little like spring steel. It's the inside of a tape measure. Kinda, it's like a little thin strip of metal. And you can put some RTV silicone in a mold on that and create a little like a springy thing that rests against your nozzle. So that's why the tool goes down into it, because it presses down onto a little springy piece of metal. So that'll be pretty cool. Also, I printed this on one of the PEO sheets. I just love that texture that it gives. It's really awesome. So that'll be cool to look at on the front of the printer. These plates are cool. And they work really well with ABS. These are all ABS parts. This is actually Polymaker's Galaxy ABS Red. I really like this color. It's an awesome red. And the sparkles, the Galaxy is actually kind of gold. So it's really cool. You gotta try this out if you have the chance. I try to use as many Galaxy colors as possible when doing a build, just because they're so much fun. No nozzle brush yet. I don't think that's necessarily needed if you have the little like ooze control. I'm looking to add a nozzle brush and like little purge bucket on the front of the print. Definitely. I'll probably end up moving the bed a little bit back so I can have a little bit more space. So we're not going to get a full 350 on the Z-axis, and I'm fine with that. I don't need 350 by 350 build volume. Like that's a lot. But 350 on one side would be great. And honestly, I'd love to build a big version of this. If this works out really well, just having like 12 tools, that would be amazing. It really would. So that would be a big printer though. The general rule of thumb is every 50 millimeters, more or less than this printer, you get one more or less tool. So this is a 350. If I wanted 2 additional tools, I would need a 450. If I wanted 9 total tools, I need a 500. This is a big printer, yeah. But compared to big printers, this is very small. You can do a second row of tool mounts. Potentially, the wiring is concerning. It's no Phoenix. No, it is. Phoenix is about to here. So it's quite a bit bigger in all dimensions. That's the issue. But what you can do if you're looking to build a really custom version of this printer, you can take the same dimensions as a 350 or whatever size you want, and then just make it wide. That's all you need. You can take a 250 and just make it double width to have extra tools. That's very possible. You can also mount whatever bed size you want on here. There's no saying that you have to have a 350. Not at all. So there's a lot of potential in this. And remember, this is at the time of this recording, this is a newer mod. That's a newer, experiment. We'll call it an experiment, right? We're experimenting with it. And until it's had many, many, many users with different parts being used and different materials tested, etc., it's going to be in beta. But I'm hoping that with the final release, we'll have some really cool features and everything will be well documented. I'm just helping out. I'm not actually developing anything. I'm just giving a lot of feedback. Yeah, we're on the bleeding edge. That's a great... We're literally on the bleeding edge. I think I've cut myself a couple times on here. Where do you put the 6 tools? That's a great question. That's up to you to decide. If you wanted to, you could put them all on just spool holders off to the side of the printer. You can put them mounted on the frame. So you can put like 1, 2, 3. You could do some cool mounts on the side. 1 on the top and then 2 in the front right here. Kind of like a Prusa XL. What I'm doing is a top hat. So I can't even really show you, but Maybe in the front view. Not really. The wires, they come up about, you know, about this much above the printer. So maybe 100 millimeters or so. I don't know what the actual measurement is, but it's probably a little bit taller than a V0 top hat. So this is 100 millimeters, so maybe like 150. And you don't have to have clearance. Like these can touch the top and kind of just sit there, but you don't want it to be like flush with the top. That wouldn't work well. So we need to have a little bit of room on top of this printer. So I'm going to be adding on a top hat to this. And then on top of the top hat, we're going to have kind of like a rep box style holder. I don't know if we're going to enclose it. I'm not sure yet, but it'll at least have 6 kind of drop-in spools. So that's also similar to the Bamboo's AMS. And I'll probably just have it sized for Polymaker spools, since that's what I'll be using most for this build. And those seem to be pretty standard size. It's not like that blue one back there. Like I'm not expecting to print 3 kg spools. And if I do want to, I can mount it on the side or on my desk, etc. We're gonna have a lot of options here. One of the tools will probably have like a side inlet, like a Y splitter, so I can feed it in from the side. We'll need to be able to feed it from a dry box. That'll be important if we want to print TPU or nylon. We'll want to print it from a dry box. So I don't know if I'm going to get too much into the config today, but I at least wanted to give an update on the printer, where it's at, and you know, kind of where it's going. So does anyone have questions in chat about the build? Let me just run that tool change demo again, because that's fun. In good news, I have ordered the rest of the parts I need. So Fabreeko will be sponsoring the fans for this printer. So all of the tool head fans. This build with 6 tools takes 12 4010 blowers and 6 3010 axials. That's a lot of fan. If you're looking to build this printer, expect to pay around $200 per tool. It might be less, might be more, but $200 is the average price per tool, including wiring, etc., etc. So it's not ridiculously cheap, but that's not crazy expensive compared to a lot of your other options, especially if you already own one of these printers. I'm sure someone has a 2.4 just collecting dust because they have other printers. Maybe they just have a Bamboo that they use for everything. Who knows? It's a cool macro. It's easy to just have it go. Got enough fans for a 5 tool head. Yep. I'm okay. Another really cool thing about this printer is, look at this. I have 2 tools. I could use this printer, calibrate it with 2 tools, and then call it a day. And then, if I have some money, I can add another tool. Heck, you can start with 1 tool. Just get the printer working. That's the coolest thing, is that it's expandable. You don't have to buy everything at once. It's a lot of money to buy, you know, 6 orbiters, 6 hot ends, 6, you know, tool head boards, 6 sets of wires. It's very expensive. It's so expensive. But compared to a Prusa XL, it might be a little cheaper. It's still a Toolchanger if it's 1. Well, this is a Tapchanger. Oh, I lost my Bowden tube. I'll fix it after. This is a Tapchanger. So it is a tap-based printer that you can swap tools on. So one of the other cool things about this printer is if you wanted to use the Tapchanger mechanism, or in this case, the Stealthchanger version with the pins, which is what I'm recommending. It's extremely reliable and very easy to build. If you wanted a Stealthchanger on your printer, you can. The only requirements is that it has to be umbilical. That's the only requirements. is that you're running umbilical, because it's just not supported with a drag chain at the moment. I'm sure you can mod on a drag chain if you really wanted to. I wouldn't recommend it. Tailwhipman, thank you for the follow. Some other options you can do. So my situation, I have a end stop right over here on the A motor mount. There's a couple mods you can do for that. There's actually a mod that I'll recommend, and it puts a printed part on top of here, and then a receiving printed part here, and then those two talk to each other. Instead of having to print it from scratch, because if you've already built a 2.4 and you don't want to rebuild it, I completely understand. So you can just add on a Y end stop switch. The X is most likely going to be sensorless most of the time. If you wanted extreme reliability and you're building this from scratch, you can add a drag chain just on the Y-axis. So you can have your drag chain right here, and you can have the stock Voron PCB for the XY, or a modified version. And that's perfectly fine. But the issue is if I go to Tool Align Start, the issue is the distance between the frame. This right here is nothing. It's not enough for a drag chain. So you can compensate for that by just getting a larger frame right off the bat. That is very possible. In fact, let me show you a couple of options. So you can cut your own frame. There's nothing wrong with that. I've cut many printers of frames, and that works fine. But you can go to DLL PDF. I'll actually leave a link for this in the video description. If you go and select the Voron 2.4 frame, you can get it whatever size you want. You can get a frame size 350 millimeters, 300, 250. And then, this is the best part. You can specify a increased Z for the printer. So it just makes it taller. That's awesome. So you can make it 50 millimeters taller, 100, 150, 200, and it doesn't add that much extra to the cost. Okay, I also have it selected as a Doom printer, or a Doom frame. That adds, I think 40 extrusions on the outside. If you want a very stiff printer, that might be worth looking into. But yeah, if you just want a regular printer with an increased Z height, and then you want it to be a fancy color, remember, DL PDF does insane colors, like purple, or, where's the really cool ones? There's glow in the dark. You can get a glow in the dark frame. Yeah, UV, reactive, glow in the dark. There's many options that you can get for colors here. And I think you can just kind of send them a color and they'll make it. Yeah, custom. Just, yeah, make it this color. Like, okay, yeah, we'll make it this color. I don't understand. Like, it's just crazy. So if you're looking to get a really custom frame for this, that is an option. But I do like the stock LDO frame quite a bit, and I really like this blue. This is probably one of my favorite colors so far. I've had most of their colors. Welcome in, Steve Bills. How's it going? Anyone know, are the Creality Winston GDS 4010 fans loud? All of the 4010 fans that I've had aren't that bad. Like, they're not quiet, but they're not loud. They're not like whiny. They're a reasonable noise, I would say. So let's show off this tool changing mechanism one more time. And I think we're gonna call it there. Because after this, I'm gonna have to, I don't wanna attempt to calibrate the tools without knowing what I'm doing. So I'll figure out how that's exactly done, and then calibrate the tools, and then figure out all the slicer stuff, all the nasty stuff behind the scenes. And then we'll go and do a video on what it's like to use. All right, let's see. Oh, I'm on my V0. Like, those aren't the right macros. Tool change demo. Here we go. That is so slow. There we go. Oh, it was like going back to where it was. That's interesting. I had it high. Oh, it's taking the same amount of time. Okay. Interesting. Well, you get to watch the world's slowest tool change. I guess I'll zoom right in on it. So yeah, much more to come with this. This is just the beginning. We have so much more that we can be doing. We'll see some printing, multicolor printing, as well as tutorials on how to calibrate this setup. I'm very excited for the future of this project. Yeah, I have it in slow-mo. It's not normally this slow. Yeah, give or take, but I'm estimating that you can build a 6-tool upgrade. If you have a 2.4, approximately, give or take, $1,500 is the high point. So $1,500 is my estimate for everything. Everything you'll need. That includes the top hat, extrusions, maybe panels, spool holders, all the tools, etc., etc. You can go cheaper, you can go more expensive. You don't have to get panels at all if you want to use it for PLA. You get options. There's definitely options. Oh my god, so slow. But that's actually not bad. You get to see like exactly what it does. There we go. Jeez. Let's bring the... Oh, let's bring it to the front here. Let's do y equals 320, x equals 320, then z equals 10, and then run that command and see if it starts from there. I think this goes up and down, but you at least see what it does. Yeah, so this is going to be comparable in pricing to an XL, probably slightly less, but you'll have to build it from scratch. So you have to value your time. Is it worth, you can get a fully assembled XL, or you can build this. It's all up to you. If you're looking for a reliable solution, you might want to go with a Prusa XL, just because, they're building their machines to be reliable, as well as high quality, and you get the support right from Prusa. So as much as the Discord is extremely helpful, they're not 24/7. And it's not, you're just relying on someone to help you. So having someone directly from Prusa might be a good option for a lot of people. So don't just build one of these expecting a flawless tool changer. Expect that you might have to put in a little bit of work, tweaking, tuning, maintaining. I'm not expecting this to be 100% perfect, but it looks very promising. I'm expecting there to be a lot of advancements in the docking mechanism, as well as maybe some like fundamental changes to how it works. So, to summarize, we're in a pretty good spot here. We're able to change our tools. We have 2 of them, and at this point, it's as simple as just copy and pasting. That's all. Yeah, we're moving at 150 millimeters on the z-axis, and we can go faster, although it starts to get a little bit louder as the speed goes up. That's the downside. But I'll have a full comparison, and we'll test it at all the different speeds. We'll see how fast we can get it on the stock LDO kit. Reasonably, though, we're going to be at 150 millimeters a second. That's reasonable to me. We're at around a 15-second tool change from stopping a layer to going up and switching tools to finishing a prime tower. It's about 15 seconds per tool change, compared to what could be a minute on a bamboo for a change. Over a minute. Yeah, ignore the colors. I have the red the red tool dock, which is tool 1, all ready to go. So I got to swap around the tools, you know, just tell them that they're different tools. And of course, clean up the cable management. There's a lot more work to do, a lot more work, but we're making really good progress, and I'm super excited for this to be working and printing some amazing models. So, that being said, this will be it for the recording for YouTube. Don't leave if you're on Twitch. We're going to have an after party. If you haven't subscribed to my Twitch channel yet, I have a link down in the video description. We do these streams very regularly, So, definitely stay tuned for the next stream. If you want to catch some VODs, I'll have some more VOD content as well. So stay subscribed to this channel. Make sure to like this video if you liked it, and leave a comment. How many tools would you want on a printer? Would you want just 2 tools? You can do that. Would you want 3, 4, 10? And what would you do with those tools? What are you actually going to print on a Toolchanger? Let me know in the video comments down below. So, that being said, thank you all for tuning in. Make sure to check out the other videos in this build series. This is episode 4, if you haven't already. Otherwise, thanks to LDO for helping with the frame and the whole entire kit itself. Thank you to Polymaker for the filament. I was able to print some really nice ABS parts with the Polymaker filament, as well as Fabreeko providing fans, and anyone else who might have provided parts or assistance along the way. Shout out to the Stealthchanger team, who's putting in a ton of effort to get this thing just perfect. It's honestly gonna be perfect one of these days. So, that being said, thank you for tuning in. Have a good night, good morning, good evening, and goodbye.